This recording is regarding for students who really struggle with factoring. And so here is the basic rules. I call them magic numbers. And it's for the expression ax squared plus bx plus c, which is the basic expression of a quadratic expression. And so we have that a and b are coefficients, and c is a constant. So we have to have two different situations to think up two numbers where when multiplied, it's whatever a times c is. And if those same two numbers are added, it would equal b. So the reason why I have MN is the acronym for magic numbers. So here's an example. We have that on number 1 is x squared plus 11x plus 28. So my a ends up being the coefficient of x squared, which is 1. It's that invisible number. My b is 11, and my constant c is 28. So if we go ahead and follow the rules where the magic numbers multiplied has to equal whatever a times c is. Well, a times c is 1 times 28, which is 28. My magic numbers added has to equal whatever b is, and b is 11. So we go ahead and make a little table here. Since 28 is positive, that means that my magic numbers are added. So we have 1 and 28, 2, 14. See, 3 doesn't go into it, 4, and 7. So we look at those factors where we add them. Well, 1 and 28, if I add those, equal 29. 2 and 14 equals 16, but 4 and 7 equals 11. And so I go ahead and I split up my x's, and it's going to be x plus 4, x plus 7. So I encourage you to work on the other one and go ahead and pause it and see if you can figure it out. So my magic numbers multiplied equals a times c. A is 1, c is 24. So 1 times 24 is 24. My m plus n, my magic numbers added, equals whatever the b value is, which is 11. So we go ahead and we do our little table. We put 24 here because it's easier to figure out the factors, and then look at those factors by adding or subtracting. Again, since the 24 is positive, that means that your magic numbers are either both positive or both negative. So we've got 1 and 24, 2 and 12, 3 and 8, and I'm going to stop right there because I can see that if I add 3 plus 8, that equals 11. So I go ahead and I split up my magic numbers, and it ends up being plus 3 plus 8. Magic numbers multiplied for this one is 42, and added is 13. So my magic numbers, when I add them together, since the 42 is positive, is 6 and 7. So then I've got s plus 6, s plus 7. This one, we have that our magic numbers multiplied equals 21, added equals negative 10. So we go ahead and make our table And I know that I've got to add my magic numbers, which is 3 and 7. But since I have to add them to equal -10, since 21 is positive, that means that the magic numbers are either both positive or both negative. So in this case, they are both negative. So I have x minus 3, x minus 7. Same thing with this. Magic numbers multiplied equals 15. Added equals -8. So I make my table. Positive 15, either they're both positive or both negative. So I've got 3 and 5. I know that when I add them together equal 8, but they have to equal -8. So my factor is y minus 3, y minus 5. Magic numbers multiplied equals 32. Added equals -12. So I know that 4 and 8, if I add those together, equal 12. So since the magic number multiplied is positive, they're both either positive or negative on the magic numbers. In this case, it's both negative. So now I've got x minus 4, x minus 8. In this part, we have to do a little bit more work on this. When we do our magic numbers and our factoring and everything, if the leading coefficient right here is -1, we have to force it to be a positive. So we go ahead and factor out the -1. So when I factor out the -1, all you're having to do is just divide -1 here, here, here. So now we have x squared. I want to use a different color so that you can see this. X squared minus 9x plus 18. So when we do our magic numbers, we factor only what's in the parentheses. So I'm going to keep the same color because that's all I'm interested in, is factoring only what's in the parentheses. So magic numbers multiplied, 1 times 18 is 18, added equals -9. So that would look like that we would add our magic numbers and they'll end up being both positive. So we have 3 and 6, and they're both negative. So I went ahead, I will go ahead and have the final factor, but I've got to remember to take the -1 out, and I've got x minus 3, x minus 6. Okay, this is something that we always fail to do, is to make the leading coefficient positive. So I've got another example over on the other side. I want you to try it and see how it goes, and then you can check it. Here we go. We factor out the -1, and we end up dividing all of this by -1 just so that we can make the leading coefficient positive. So now what we're going to factor inside is w squared minus 12w plus 35. Magic numbers multiplied equals 35, added equals -12. So since it's multiplied to a positive number, either both of them are positive or both of them are negative. 5 and 7 are the magic numbers, both of them are negative. So now we have -1 times the quantity of w minus 5 w minus 7. Next thing is that whenever you need to factor something like this, sometimes you may not be able to go all the way to the end, but you would still need to check first the GCF. Whenever you have a binomial like this, where there's only two terms, look at the GCF first, and then check to see if there's difference of squares. So on this one, the GCF between 6x squared and 9 is 3. So I will factor out the 3. And so that means I'm going to divide both of these terms by 3. And so I have 2x squared minus 3. Really can't go any further. There isn't any difference of squares inside the parentheses. So this is already in factored form. On this one, it has both numbers and variables, that is the GCF. So if we look first at the numbers, we have 16 and 8, and the GCF between 16 and 8 is 8. Whenever you have variables, the GCF is whatever the lowest exponent is. If I've got m squared here and I have m here, well, the smallest exponent is just m. And so my GCF between these two terms will be 8m. So I divide by 8m. And so I have 2m plus 1. And if you go backwards, because whenever you use GCF, it's basically on distributing. So if you go back to the distributing and check your work, then you'll definitely know whether or not if you're on the right track and if you've factored it correctly. I know that we don't deal with fractions too much when factoring, but I still want to expose you to this. So since we have 1/3 x squared plus 1/3 x minus 4, then we want to have our a and b to be whole numbers. So we end up factoring out the 3. And so basically we're just multiplying. If you multiplying by 3 here, and so we have x squared plus x and then minus 12. This is still GCF, and so if we were to go ahead and I actually caught myself with an error because I went back and I distributed. It's not the 3 that you would factor out, it's the 1/3. So if we were to go back and distribute that, it should go back to what we were beginning with. The reason why we can multiply by 3 is because 1/3 divided by 1/3, I believe, is just 1. Yes, it is. So magic numbers, let's get to the magic numbers. So magic numbers multiplied equals -12. Added equals 1. Since my magic numbers multiplied is a negative, then that means that I have to subtract my magic numbers. So if I go 1, 12, 2, 6, 3, 4, if I go 12 minus 1 is 11, 6 minus 2 is 4, 4 minus 3 is 1, so I know my magic number is going to be this. And so it depends on which one is negative. You got to choose whichever one is negative. Since the 1 is positive, then the largest number, which is 4, stays positive. So we have 1/3 times the quantity of x minus 3, x plus 4. On this next one, there's a couple of things that we have to do. GCF, if we look at 7, 7, 14, then we know our GCF is going to be 7. Since we have a leading coefficient that's negative, we want it to be positive. So we're going to divide all of this by negative 7. So we have x squared plus, or excuse me, minus x minus 2. So we're only going to factor whatever's inside the parentheses. So magic numbers multiplied equals negative 2 added equals negative 1. So if we've got negative 2, the only factors that we have is 1 and 2. But if we subtract that, it equals negative 1. Or excuse me, 1. And so 2 minus 1 is 1. To make the decision as to which one that you use for a negative, since the magic numbers added equals a negative 1, then the largest number is negative. So we're going to bring down the negative 7, and we're going to have x plus 1, x minus 2. What we've done in the past is we've had to either use GCF or use our magic numbers. We still use the magic numbers, but whenever we have a leading coefficient that's bigger than 1, then we have to split that up and then simplify it. We got to reduce it. So if we have our magic numbers, remember we're trying to stay as consistent as possible, so that if we have our magic numbers multiplied, it's whatever 2 times 10 is, which equals 20. And our magic numbers added equals whatever our B value is, which is 9. So we go ahead and we do find our factors, and so we already know that we would add our magic numbers, so we have 4 and 5. Okay, this is the step that we tend to forget. All we have to do is just kind of figure out how we can reduce it. We've got to have a starting place somewhere. We tend to go ahead and say x plus 4, x plus 5, and in reality we can't do that. Okay, because if you go back and check it, it doesn't work out that way. Well, since we both have the 2x's right here, that would equal 4x squared, which is too much. So we have to reduce one of these factors. We reduce this factor by 2, and so now we have x plus 2, 2x plus 5. And we can always go ahead and check it. So the first x times 2x is 2x squared. 2 times 5 is 10. Here we have 4x. Here we have 5x. And when we add those together, equal 9x. Magic numbers multiplied is whatever 6 times 1 is, which is 6, added is negative 5. We tend to really get mixed up between the factors of 6 and then we have 5, because we have to make it, we've got to test it. So here we know that it's positive 6, and our factors is 1 and 6, 2 and 3. Well, we tend to want to use 1 and 6 because 6 minus 1 is 5, and it's negative 5, and so we got to be very careful with that. Since our magic numbers are positive, that means, or right here, since this number is positive, that means that we've got to add those magic numbers, and 6 and 1 is 7. So that doesn't work, so we have to use this one. And so remember, either both negative or both positive. In this case, it's both negative. So let's go ahead and go 6y minus 2, 6y minus 3. Both of these can actually be reduced. And it doesn't have to be the same number. So let's see if this works. So this is 3y minus 1 and 2y minus 1. If you test it, you'll be able to see that when you FOIL it or multiply it or whatever method you use, it will go back to 6y squared minus 5y plus 1. So I'm using a lot of examples here that have the leading coefficient bigger than 1. So magic numbers multiplied on this one is negative 9. Magic numbers added is 8. So if I put negative 9 here, that would mean I've got 1 and 9, and I've got 3 and 3. So magic numbers subtracted has to equal 8. Oh my gosh, my dogs are like on a mission. They were about ready to make a racket. All right, so we know that we have to subtract our magic numbers, and so 9 minus 1 is positive 8. And so this, we have to keep the bigger number positive. So let's do our 3x minus 1, 3x plus 9. Just always, if it helps you to remember, always just split up the first term. We do that even with the leading coefficient to be 1. If I've got 3x squared right here, I'm just going to stick 3x on both of them. This one's too big, so divide by 3. So I've got 3x minus 1 x plus 3. This one took a little bit more work because magic numbers multiplied has to equal negative 60 and added has to equal negative 7. And so just kind of played around with it, figuring out, okay, well, what numbers would work since it's negative. I know I've got to subtract my magic numbers. And so I finally found it where it's 12 and 5. Since my magic numbers added is a negative number, that means that my largest number has to be negative. It's hard for me to write it, but it's got to be negative 12. Let me see if I can put it. It was really hard to write that, but anyways, let's go ahead and let's split it up. We've got 4x plus 5, 4x minus 12. This one's too big, so we go ahead and reduce it. So we got 4x plus 5 and x minus 3. This one, always good to look at the GCF. If I've got 12, 10, and 12 right here, then I know that my GCF is, let's see, I take the largest number, so 2 and 6, 3 and 4. So it looks like it's only 2. So I'm going to go ahead and factor out the 2, and so I have 6, t squared. Plus 5t. Minus 6. Let's see if this works. magic numbers multiplied equals negative 36. Added equals 5. So let's see, I won't put it quite so close to the edge. Negative 36, since that number is a negative, I gotta subtract my magic numbers. And so what first thing that comes to mind is 9 and 4. Since my magic numbers added is a positive number, which is 5, that means that the largest number has to be positive. So it becomes, the 4 becomes negative. So we go ahead and go 6t plus 9, 6t minus 4, and it looks like we can reduce both of these. This one by 3, this one by 2, so we have 2t plus 3, 3t minus 2, and then don't forget to bring down what you've factored. So it should work. Let's see. So I'm just interested in the middle, what I've factored. 2t times 3t is 6t squared. 3 times negative 2 is negative 6. This is 9t. This is negative 4t, so it's plus 5t. So it works. That's just checking it. It's always good to check. This next one was really hairy, and some of the stuff that we're working on, I don't think it's going to be anything like this. So I already have the magic numbers right here. So since our magic numbers multiplied equals a negative 210 and added equals negative 1, I went ahead and gave you the magic numbers. So since it's negative 1, the largest number is negative. So I went ahead and I also, right here, took out the negative 1 because I want the leading coefficient here to be a positive number. Positive 10, not negative 10. So then we go ahead and go 10x plus 14. 10x minus 15. This one can be divided by 2. This one can be divided by 5. So we have 5x plus 7. 2x minus 3. But again, I don't want you guys struggling on this one too much. Just so that you get the gist as to how to do the steps on factoring. That's all I have. And so if there's any other questions that you might have on factoring, I can go ahead and just include them on a recording. So I'm hoping that this will help you guys out. I want this group of students here to be able to factor. You have to be able to know how to factor and be comfortable with it, especially when you get into calculus. So we'll see you later. Bye.